Alright, let's look at the homework 6, problem number 17. Alright, so we want to find the equation of the tangent lines at the point of the graph y squared minus xy plus 12 equals 0, where x equals 8. Alright, so first we want to find the corresponding y values when x equals 8. So let's do that. Alright, so we just need to plug in 8 where the x is, right? So you get y squared. Right, now 8 is plugged in, so it's a negative 8y and plus 12 equals 0, right? So this gives us, right, so you have a quantity, right, y, let's see, and a y, let's see, we have two numbers, so it's at 2 and 6, so negative 2 and the negative 6. Would that work? Right, equal to 0, so multiply these together, you get positive 12, add them up, negative 8. Right, so y value is y equals 2 and also 6. Right, so let's type it in. It's 2 comma 6. Right, check the answer. We got that. Right, tangent line at 8 comma 2 is, right, so we just need to find, so we have a point, so x1 comma y1, so this is 8 comma 2, and we need to find the slope, right? So we need to take the derivative. So we take that equation without plugging in 8, and we're going to take the derivative with respect to x. Right? So derivative of y squared is 2y times dy over dx. Right? And derivative of negative xy would be, we have to use the product rule. So I'll take first guy to be negative x and second guy is y. Right? By product rule, derivative of the first guy is negative 1 times the second guy y. And the first guy is negative x times the derivative of the second guy, which is dy over dx. Alright, derivative of 12 is 0, derivative of 0 is 0, so this is equal to 0. Right? And the first thing I would do is I'm going to move this term over to the other side. So this term over to the other side. So we can simply add y. Right? Then I'm going to actually combine so that these two guys together. So you have dy over dx in both terms. So I'm going to just combine it. Right, then I'm gonna put dy over dx, right, and what's left here is 2y here, 2y, and minus x, and this is equal to, so this term negative y becomes positive y on the other side, right. Then we can just isolate dy over dx, divide through by 2y minus x, right. So we have a dy over dx is equal to y over 2y minus x. Right? So all you have to do is plug in, let's see, 8 comma 2. Right? So y is 2 over, and the y is 2 again, so 2 times 2 is 4. Minus x is 8. So this is 2 over negative 4. So that will be negative 1/2. Right? So the equation is going to be y minus y1, which is 2, is equal to m is negative 1/2 times quantity x minus x1, which is 8. Right? So I'm going to go ahead and distribute negative 1/2 to x and the negative 8. We get negative 1/2 x and plus 4. Right? And we can isolate y by adding 2. So you have a y is equal to negative 1/2 x and adding 2. So this is going to be 6. Right? So let's type it in. Right? So it's a negative 1/2 x and plus 6. Right? So plus 6. Alright, let's check the answer. Oh, sorry. I didn't put y there. Here. Y is equal to, right, here. Alright, we got that. Alright, so let's look at the tangent line at 8, 6. Alright, so only difference we have to make is the point is different. So here, so x1, y1 is 8, 6. Right? Then we just have to use the same derivative. So here, y value is 6 in this case, so 6 over, right, 8 times, so 2 times y is 12, minus x is 8. So this is going to be 6 over 4. Right? So this gives us 3/2. Right? So the equation is y minus 6 is equal to 3 over 2 x minus x1. Right? Actually, I'm going to type in exactly like this and see if it will take it. Right? So it's y minus 6 is equal to 3/2 times x minus 8. Alright, check the answer. Alright, it takes that form too. Alright, that's it. I hope that this was clear.